In this last session we will make our model probabilistic in order to be able to run a Monte Carlo simulation, also called probabilistic sensitivity analysis. We will add this button here, and when we press this button the model will switch from deterministic to probabilistic and run a Monte Carlo simulation with 1000 iterations. For each iteration, variable values will be randomly sampled from the probability distributions. We will get the results from the Monte Carlo simulation in the ICER scatterplot and in the cost-effectiveness acceptability curve. The calculations from the Monte Carlo simulations will be on a sheet called simulation, and we will keep it rough like this because we will hide it in the end. Here we have iterations of our simulation. It goes from 1 to 1000. For each iteration we register cost and qualis from the new drug and the old drug. Here we calculate incremental cost and qualis, and these two columns are actually the base for the ICER scatterplot, this graph. Further to the right on this sheet we have the calculations for transforming the ICER scatterplot to a cost-effectiveness acceptability curve. We calculate the net monetary benefit for the new drug and the old drug. And over here we register the probability of the new drug to be cost-effective compared to the old drug over a range of willingness to pay. This is the data used to create the cost-effectiveness acceptability curve. We start with adding a new sheet. I press here and I call this simulation. On this sheet I will keep track of the iteration of the simulation. It will go from 1 to 1000. So I grab this and just pull it down. 7, 8, 900 and 1000. Here we stop. For each iteration we will collect costs and qualis for the new drug as well as for the old drug. Copy this. I actually add a column here to keep it separated, and I will keep this one separated as well from the incremental cost and qualis over here. Incremental costs, qualis, and we will have the ICER. The Monte Carlo simulation will work like this. We will switch from a deterministic model to a probabilistic model. Now, when we have a probabilistic model, the variable values are not fixed, but instead randomly sampled from the distribution. So every time I press F9 now, we will have a new random sampling. See how they switch all the time. And each time we get a new set of variable values, we get a new set of results. And that's what happens each iteration. So first iteration, we press F9 to randomly draw new values from the distributions. We register these results, go to sheet simulation and write them in. Cost for the new drug, qualis new drug, cost for the old drug, qualis for the new drug. And we will get the incremental cost and qualis and the ICER based on these results here. Then we go back and make a new random sampling, press F9, we get new results here, we take them and we write them into second iteration, cost qualis, and get new incremental cost and qualis and a new ICER. And so on 1000 times. But instead of doing that manually, we will write a macro to do it automatically for us. To create a new macro, I could go to Developer, Record Macro, and start recording something, stop it, then go to Visual Basic and clean it up and write in the new code as we did the first time with the macro time horizon. Or I could go directly to Visual Basics and write it from scratch. So this is module 1 and we have our macro time horizon here. I scroll down to the end and I write sub simulation. I press enter and we will get the end sub automatically here. So here we will write the code to run the Monte Carlo simulation. And let's start with some comments to get the structure right. I insert a comment with this apostrophe. First we will switch to a probabilistic model. Switch to probabilistic model. And you see this comment code is in green. Then when that's done, we will press F9, which is the same as sampling new variable values. Sample variable values from the distributions. Then we will get the results from sheet start page to sheet simulation. Get results to sheet simulation. And we should do this for 1,000 times. Do 1,000 times. So we should press F9, get new variable values, get new results, get the results to sheet simulation, and write them in there on the right iteration. Loop it up, do it again and again and again 1,000 times. Then we come down here, we exit the loop, and we could switch back to deterministic model. And then the simulation ends. So this is going to be the basic structure of our macro. Before we write the code for the macro, let's declare a few variables that will help to speed up the macro. And we do that by writing dim, and we will have a variable called costs old, and we write as double. This means that we have created a variable called costs old, which is of the type double. And this means that it can hold several decimal points. We create another variable, collies old, as double as well, and then the same thing for new. Dim costs new as double, dim collies new as double. And we will also declare a variable called I as integer. Integers are whole numbers like 1, 2, 3 and so on. These variables will be handy later on in the macro. Now we start with the macro code. Switch to a probabilistic model. How can we do that? We have this cell link here that we call prob. When this cell is 1, we have a probabilistic model. When it's 2, we have a deterministic model. So we will force this cell to be 1. We do that by writing range prob, which is that specific cell, equals to 1. So whatever it was, turn to 1 now. And we could go down here and turn it back to 2 directly. Range prob equals 2. So now it switches back to a deterministic model. Then we should press F9, get new variable values, get new results, get them to the sheet simulation, and do that for 1,000 times. So here we need a kind of loop. And we will use this I here, the integer, to do that loop. We write for I equals 1 to 1,000. Do this, and then do it once again for next I. So this will go here up and down 1,000 times until I becomes 1,000. Every time the computer comes down here, I will be added by 1. So the first loop, I is 1, goes down here, I becomes 2, goes up, goes down, I becomes 3, goes up, until I is 1,000. Then it just skips this and runs from here, changes to prob to 2, and ends the macro. In the loop we have this press F9. The code for that is simply calculate. If you don't know this code, just try to record a macro, press F9, go back and see the code for it. Get the results to sheet simulation. Here comes the tricky part. We will use these variables here to save in the results, and then we will go to sheet simulation and write in the results based on what we stored in these variables here. In our model we have the results here on sheet start page. Cost new drag, cost old drag, collies new drag, and collies old drag. And these cells here are linked to sheet old drag and sheet new drag. We see up here that this cell just equals total cost new. We find that cell right here. This cell has the name total cost new. So here we actually have the results from one iteration. When we press F9, these results will update like this. We could just copy this value, go to sheet simulation, paste it in, go back, take the qualis, copy it, paste it in, and then do the same thing for the old drug. But that will slow down the macro. If we instead use these variables, it will be quicker. So first we will just save in the results in the variables. And we will write that like this. Costs old equals range total costs old. The range total cost old is found here on sheet old drug, right here, total cost old. So what we did now was to say to the computer, save in this value here in our variable costs old. We do the same for qualis. Qualis old equals range total qualis old. And the same thing for the new drug. Costs new equals range total costs new. Qualis new equals range total qualis new. Now we will have the results stored in these variables here. Next step is to go to sheet simulation and write in the values there. So we write sheets simulation, select. This code takes us to sheet simulation here, and let's add some numbers here to help orientate. And I will put up our code here next to, so we see what we're doing. What we want the computer to do is to put in the costs for the new drug here, qualis for the new drug here, costs for the old drug, and qualis for the old drug. We start with cost for the new drug. We can refer to this cell here using these numbers. I write cell, I write cells. It asks for row index. Row is 11, but it will only be 11 during the first iteration. The second iteration we want to be 12, the third iteration 13, and so on. So here we will use our variable I, which increases for each loop here. So I will write 10 plus I, which in the first iteration is 11. Column index will be 5. Value equals, and here we should have the cost for the new drug, which we stored up here in this variable, costs new, costs new. Next cell we have the qualis for the new drug. Cells, again we're gonna have 10 plus I, it's on row 11, but now it's in the 6th column, so we will write 6 here. Value equals qualis new. Next cell is still on the same row, but the 7th column. 10 plus I, 7. Value equals costs old. And finally, we have the qualis for the old drug, which are in column number 8. Value qualis old. Let's see what we have. Declare this variable so we have something to work with. Switch to probabilistic. Do this for 1,000 times now. Calculate, that is random sampling. Save in the results and write in the results. Let's check if this is working now. So we switch to deterministic model and I press F8 here. Next time I press F8 it will jump down here directly. Just skip these. They are not happening in the Excel file, just in the macro here. Switch prob equals to 1. Now when I press we should get probabilistic model here. Yes. For I equals 1 to 1,000, and when I hold it over here we see I is now 0. When I press here I will become 1. So now I is 1 and it will increase each time we come down here. Here it will become 2, 3, 4 and so on. Calculate. When I press here we will get new random samplings of these variables, which will result in new results here. So let's see this. I press F8. Yes, all the results were updated. I is still 1. So let's see. total cost of the old drug is 482,698 Swedish crowns. When I press F8, that value will be written into this variable. You see, and here we get all the decimal points as well. Just hold the mouse over the variable and you see the variable values. Press F8 again and we will have the collies old 6.75, that's correct. Cost new 494, yes, correct. And the collies new 698, correct. And now we switch to sheet simulation. Now let's see, it will start in this cell if we have written it correctly, and it will write in the cost new, which were 494,085. I press F8, correct, and the qualies of the new drug 6.98, that's correct. Cost of the old drug 482,697, correct, and qualies old 6.75. So the first loop was correct. I press F8 now, and I will increase to from 1 to 2. I is now 2. Do the same thing, calculate, write in the results, go to sheet simulation, and now I here is 2, so it will jump down one row and write in the results. Like that. I will become 3. Same thing will happen again with new random variables, new results. It will continue like this for 1000 times. And we don't need to press all this, we can actually press F5 and the macro will run to the end. But I will make it stop here just to show the last thing. So when I press F5 now, the code will run until down here and stop, and it will loop this for 1000 times. I press F5. Okay, here we go. The macro has come down here, and let's just check that we have 1000 different results. It went down to 1000 exactly. And last thing the macro does is to switch back to deterministic model. I press here to get away the red stop and press F8. Let's check. Now we have deterministic model and the macro stops. Incremental costs, that's the difference in cost between the new drug and the old drug. That means this value minus this value. Incremental qualies, that's the difference in qualies. Qualies new drug minus qualies old drug. And the ICER is the incremental cost divided by the incremental qualies. Let's make this look a bit better. I format this number to number, no decimal places, use 1000 separators. And I center it and use the same format on the costs. For the qualies, I use 2 decimal places and I center it. Then I highlight these 3 cells and just drag it down for the whole column. Like that. So here we see that we have specific incremental costs and qualies as well as a specific ICER for every iteration. Here we see even a case of dominance. We see that during this iteration the new drug resulted in greater health effects and also cost savings. When it looks like this, it's just because the cell is too tight. The ICER scatter plot is a chart with the incremental costs on the y-axis and incremental qualies on the x-axis. And we have the data for that right here. To create the ICER scatter plot, we highlight all this data. I press Ctrl Shift down arrow, so I highlight the whole column. I go up again, and I choose to insert a chart, and we will choose this scatter this type. And this is what we get. It looks like we have the cost on the x-axis and the effects on the y-axis, and we want it the other way around. So I right click on the graph and choose select data, and in here I enter series 1, edit, And here we see that for the X values we have from the J column, which are the costs, but we want that on the Y-axis. On the Y-axis we have from K column, which are the qualies. So let's just switch that. I write in K here and here as well, and I use my mouse to switch position. If I would use the arrows, it would probably mess around in the sheet. And I write J here and J here. And I press OK and OK. Here we go, now they've switched. So let's make this graph look better. I take away this here and I will remove the grid lines. I select them like this and just press delete. I will make these numbers bold and a bit bigger, size 12. And let's just make them have one decimal point. I double click on the x-axis and here I can control that. I will use one decimal place. Close. I do the same formatting on the y-axis. I make it bold and size 12. I want to change the shape of all these dots, so I just double click here in the cloud. And here, marker options, I can choose what form they should have. I will choose built-in and this circle. Size 7, I'll keep that. Marker fill, no fill. I will just have a circle around it. Marker line color, automatic solid line, and we will have this color here. We could change to anything else, but let's keep it blue. And I close it. And they look like this. Let's add some axle titles. One here for the x-axis, one for the y-axis, and one title for the entire chart. I go to layout, and these chart tools are visible when I have selected the chart. When I'm out here in the sheet, they're not visible, but as soon as I click on the chart, they pop up. So on layout, I go to axis titles, x-axis, and here I write incremental collies or collie. Control A to highlight it all, and I will make them bigger. I choose 14. And for the y-axis, we choose this rotated title, incremental costs, and in this case we have Swedish crowns. And I make this bigger as well, 14. So let's tighten the chart area a bit smaller like this, and I move this title further to the left. These titles are right there. And then the last thing, the title for the whole chart, layout, chart title, centered overlay, ICER scatter plot. And I will give this a color gray, like that, and just move it to the corner here. Something like that. And this chart, we want to have it on the start page, so I just select it and press copy, Ctrl C, and I go to the start page, choose a spot here and press Ctrl V to paste it in. We will adjust the size later when we also have the cost effectiveness acceptability curve here. This is now linked to sheet simulation, so when the numbers are updated here, this chart will be updated as well. And I can actually remove this chart here. To create the cost effectiveness acceptability curve, the SEAC, we will use the same data as for the ICER scatter plot, that is the costs and qualies for the new drug and old drug from each iteration. We will start with calculating the net monetary benefit. Net monetary benefit for the new drug and for the old drug. And the net monetary benefit will be based on a willingness to pay. and we just enter something here, 500,000, to have something to work with. During the first iteration for the new drug, we gained 7 qualis, but to a cost of about 500,000 Swedish crowns. The value in monetary terms of the 7 qualis depends on the willingness to pay. In this case, it's 7 times 500,000 Swedish crowns. To calculate the net monetary benefit, we take what we gain, which is the qualis, times what the quali is worth. And I will here use the dollar signs to lock this cell here, because I will drag it down later. So I press F4 and I get these dollar signs. And I put this whole thing within parentheses. So that is what we gained in monetary terms minus what it costed. This value here. And I press enter. I will use this format here for the net monetary benefit. About 3 million was the net monetary benefit during the first simulation for the new drug. For the old drug, it's the same calculation, but with these costs and these qualis. So I just copy this cell, Control C, and paste with Control V. I double click to move these cells to the right position, and I press enter. The net monetary benefit for the old drug was only 2.6 million Swedish crowns. So during this iteration, the new drug was cost effective compared to the old drug, given this willingness to pay. I drag this down for all the iterations, like that. We want a column here indicating when the new drug is cost effective compared to the old drug, and we will do that with an if statement. So if this cell has a higher value than this cell, please return a number 1 to us, otherwise a 0. I close it and press enter. I center this and I double click to get it automatically down the whole column. So we see that in most cases the new drug is cost effective compared to the old drug, but in some iterations it's the other way around, marked with a 0 here, for example, and here, and so on. And up here we will take the mean of all these numbers, which will give us a probability of the new drug to be cost effective compared to the old drug. So here I write average, and I highlight the whole column down to 1000. I close it with a parenthesis and press enter. This command here, average, is language specific. So if you're using Excel with another language than English, you will need to write something else here than average. If you don't know what it is, download the file from the website, open it, and check what this converts to. So in this case, with a willingness to pay of 500,000 Swedish crowns, we had a probability of about 95% that the new drug was cost effective compared to the old drug. Now further here to the right, we will add some information that will be used later in the macro that will create the cost effectiveness acceptability curve. We will have here a range of willingness to pay, and in this column we will enter the probabilities of the new drug to be cost effective compared to the old drug, like this. We start with a willingness to pay of 0, and we use increments of 25,000 Swedish crowns. And I increase this until we reach 1 million. The values in this column will be fed from the macro that we will create further on. To create the cost effectiveness acceptability curve, we need the probability of the new drug to be cost effective for every willingness to pay here. And we get that by copying this willingness to pay to this cell here. Now the net monetary benefits are updated because they are based on the willingness to pay. And we have a new average here, a new probability of the new drug to be cost effective. And we copy this to this column here, and I can't use a normal Control V copy because then it will just copy the formula like this, and we'll get the division 0. So instead what we use is right click and go to paste special values, and we get the value only. Then we take the next willingness to pay, copy it here, we get a new probability, paste it in here, paste special values, and so on for the whole range of willingness to pays. When we've done that, we can create a chart with the willingness to pay on the x-axis and the probability of the new drug to be cost effective on the y-axis, and that's exactly what we need. But instead of doing this manually, we will create a macro that does this automatically. So let's go to Developer, Visual Basic, and check out our macros here. We have Simulation over here. This is the loop to write in the results, and we switch back to deterministic model, and down here we can start to write in the macro for the cost effectiveness acceptability curve. We just start with writing in the structure. I write a comment here, SEAC. First we should copy the new willingness to pay. Copy new willingness to pay. That means copying this value to this cell, and then this value, and this value, and this value, and so on. Then we will copy the probability of cost effectiveness to the right column. Copy prob C to the column. That means copy this value to this cell, then to this cell, then to this cell, and so on. Then we will do this for all the willingness to pays, and let's check how many we have. We have 41 willingness to pay, so we need a loop here again. Do 41 times for all willingness to pays. We will use some kind of loop to do this. Declare two new variables to use for this macro. The first one we call WTP, willingness to pay, as a double, and the other one prob C as a double. These will help to speed up the macro. We could copy and paste back and forth here in the sheet, but using these variables will speed up the macro. Here we start the loop for I equals 1 to 41. Do these things and then loop again. Next I. And what should we do? We should copy the new WTP. That is to copy this willingness to pay to this cell during the first turn of the loop, this value to this cell during the second turn of the loop, and so on. We will do this in two steps. First we save in this value in the variable WTP, and then we put that value here. So our variable WTP equals, and here we need a dynamic cell reference because this will change with the turns in the loops. So I write cells, I'll just make this smaller so I see what I'm doing. This is on row 11 and column 18, and I is 1 during the first turn, so 10 plus I will be 11, row 18, like that. And then this cell will have that value. So range, this is 05, value equals whatever we put in this variable here. That was the first step. Then the second step is to copy this value here to this column. And this will also be a dynamic cell reference because this has to change with every turn in the loop. We save in the value prob C equals range, and this is range P10. Then cells, and this one starts as well on row 11, but this is in column 19. So 10 plus I, column 19, value whatever we put in the variable prob C, and then just loop this 49 times, get out of the loop, and end the macro. I take away the comments here. Oops. Can make it look better like this. It's easier to see what we're doing. And let's just add a piece of code here to be sure that we work on the right sheet. We choose Sheets, Simulation, Select. It's very easy to later write in some code here that will take the whole Mac to another sheet, and then these calculations will be performed on another sheet than what we want on the sheet simulation. So let's just enter this piece of code to be sure. We test the macro using F8, so I put the mouse anywhere in the macro simulation, and I press F8. And now it jumps up to the start of the whole simulation, but we actually just want to test this little last piece of the whole macro. So I grab this yellow arrow with my mouse and I drag it down all the way down here. Come on. And it won't make me stop here on these declarations, so I will stop here where it changes the model to deterministic. And like this, so we see what we're doing. Okay, I press F8 and now these variables have been declared. Sheet simulation, we are already on this sheet, but just in case. Start a loop. I has become 1. Collect the first willingness to pay into this variable. 0, that's the first willingness to pay, the one here. Put that willingness to pay in this cell 05 here. I press F8 and that happens. Now collect the probability of cost effectiveness, this value here. Press F8 and I hold my mouse over to check that the right value has been entered. Yes. And then write in this value in this column here, and I will here delete what we had. And press F8. Correct. Then loop this again. I has become 2. Save in a new willingness to pay, this time 25,000. The willingness to pay over here. Put it up here. We have a new probability of cost effectiveness. Save in that value and write it in here on the right row. Like that, and so on. And we see how the probability increases with the willingness to pay. And I choose now to press F5 to finish this. And I just check that it has gone down the whole way. So when the willingness to pay is 1 million, the probability of cost effectiveness is 96% more or less. This is all the data we need to create the cost effectiveness acceptability curve. We highlight these two columns and insert a chart, and we're actually going to use a scatter, this one, and it looks like this. Just bring it up. So let's take away this label, delete. I select the grid lines and delete them. I want the maximum to be 1 million Swedish crowns here, not 1.2, so I double click on the x-axis and choose maximum to be fixed to 1 million, and I also change the major unit to be fixed to 200,000. And let's make them bold and a bit bigger, like 14. No, sorry, 12. Could also use actually number, no decimal places, but use 1000 separators. Like that. For the y-axis, I double click and I choose a maximum of 1, which is 100%. Major unit 0.1, increased by 10%. And we will use percentage here. Percentage and no decimal places. Close. And we make it bold as well and size 12. I want to remove these dots on the line and just keep the line, so I double click on them. Marker options, none. close. To add chart titles, I go to Layout, Axis Titles, Horizontal, Title below axis, and here we have Willingness to pay. Swedish crowns per collie. We'll make this size 14. And on the y-axis we have probability of cost effectiveness. Probability cost effective. Size 14 as well. And a title for the whole chart. SEAC, and I will make this one gray. Move it to the corner here. I reduce the size of the graph, something like that. Maybe make this one a bit lower down and the graph a bit bigger like this. And I copy the whole graph to start page next to the ICER scatter plot, and I put it right over to give it the same size. Here we go. Done. We just have a few things left to do before the simulation model is complete. We will insert here a button for running the Monte Carlo simulation. We will hide the sheet tables, etc., and also the sheet simulation. We will insert some extra code to the macro so it won't jump back and forth when we run it. If we would run the Monte Carlo simulation now, it would go back and forth to sheet simulation, back to start page, and so on. And we will insert a counter here so we know at what iteration the Monte Carlo simulation is at, between 1 and 1000. So the first thing we do is to just hide this sheet, tables, etc. Click on it and then right click and choose hide. So now it has disappeared, but it's still there and everything is still working just fine on it. If I right click on any of these sheet names, I can choose unhide and I get the sheet back like this. But now let's hide it. Next I will create the button for the Monte Carlo simulation. I go to Developer and choose to insert button form control. And I put it right here. And here we have to choose to what macro it should be connected, and this is for the simulation, so it will run the Monte Carlo simulation. Okay. So now if I press this button, the macro for the Monte Carlo simulation will start to execute. I will change the text here from button 6 to simulation. I just right clicked to get into that menu. And I'll make it bold and bigger. Let's say size 16. Let's try to run a Monte Carlo simulation now. I check the settings here. It will change to probabilistic automatically, so I don't have to change that. And before I do anything, I just save my file if something would go wrong now with the macro. Control S to save. Then I press this button and let's see what happens. So it goes to sheet simulation and all the calculations are performed on this sheet. I will pause the recording and continue when the simulation is done. Now the simulation is done and it all stopped here on sheet simulation. We got new numbers here in these 4 columns, and we got new numbers here in the probability of the new drug to be cost effective, which gave us a new ICER scatter plot and a new cost effectiveness acceptability curve. But we would like to have this macro to work only on the sheet start page, so when we press this button we will see the results pop up in the ICER scatter plot, and then in the end also the cost effectiveness acceptability curve. We're not interested in being on the sheet simulation, and we will actually just hide this sheet later as well. And we will do that by entering some extra code into the macro. First thing is to delete the old results when a new simulation is started. That means that when a new simulation is running, the first thing that happens is that these 4 columns are completely deleted, as well as this column here. And if we don't know the code for writing that in a macro, we can just record a new macro deleting this and paste that code into our original macro. So I go to developer, record macro, and I just call it test. I select these columns and I press Ctrl Shift down arrow to select it to the end of the column, and I just press delete. And I do the same thing with this column. Delete. Stop recording. I go to Visual Basics to see the code for what I just did. Make this a bit bigger, and I choose to view the Project Explorer. This new test macro probably ended up here in module 2. Yeah, here we have it. Test. So I copy this code, Ctrl C, go to module 1, and I choose macro simulation. The clearing of the results should happen quite early in the macro, so let's put it here directly after the declaration of the variables. Clear up old results. And I paste with Ctrl V. We add a piece of code to make it go to Sheets Simulation. Sheets Simulation. Select, and on this sheet select this range and selection and Excel down. Yeah, that was the Ctrl Shift down arrow. Then the whole column are selected. Selection clear contents, that's delete. And then the same thing with the probability of cost effectiveness. I selected a range. Select the whole column down and clear the contents. And we will check later on that this really works. Here we will insert the counter. The cell will say iteration. Here we will have a number between 1 and 1000, and that will be inserted automatically by the macro. Now I just write any number, and this cell will say out of 1000. We format this to bold and size 16. The idea is that when we run the Monte Carlo simulation, we will be able to see here what iteration the simulation is at the moment. When the macro starts to run, this text will appear, the count will go from 1 to 1000, and when the macro is done, this text will disappear. And that is what we will add now to our macro. Here is our macro simulation. Clear up the results, switch to probabilistic, and this is a good place to add that text actually. So plus insert counter. Just to be sure that we are on the right sheet, let's just add this code. Sheets start page, select. Then we should have cell F9 should say iteration, and cell J9 should say of 1000. Range F9 equals iteration. Range J9 equals of 1000. And again, if you don't know how to write this code, just record a macro when you write it in the sheet and copy that code into your macro. Then we go down to our loop, where this variable I goes from 1 to 1000, and we will use this variable to make the counter go from 1 to 1000. So the first thing that will happen here is that range H9 will be equal to I. Range H9 equals I. And just to be sure here again that we are on the right sheet, we copy this code, sheet start page select. And finally, in the end of the macro, we should delete this counter. Let's do that here. Switch back to deterministic model, plus delete counter. And again, just to be sure that we are on the right sheet, I press Ctrl V to paste in the code sheet start page select. Here, this whole range is to be deleted. It goes from F9 to J9. Range F9 to J9. Select. This means select all cells between the cell F9 and the cell J9. And with this selection, clear contents, delete everything. And again, if you don't know this code, just record a macro and copy paste the code into your macro. To make the macro for the Monte Carlo simulation stay on sheet start page all the time and not go over to sheet simulation, we will add some extra code to the macro that freezes the updating of the screen. This is the macro simulation, and already in the beginning it will jump over to sheet simulation unless we do something. So right here I will enter some code to freeze the updating of the screen, and this is the code for that. Application screen updating, I press tab, equals false, enter. Now this code here will be executed, but we won't see it on the screen. It will go to sheet simulation and delete all the results, but we will not see that. We continue down, switch to probabilistic model and insert counter. We want the counter to be visible, so here we have to add some code to make the screen update again. I copy this code and paste it in and just switch to true. Then the code goes into the loop. Here is the I for the counter. Get results, and here we go over to sheet simulation again. So we need to enter the code to freeze the updating of the screen. The loop ends and goes up, but now the screen updating is freezed and this won't be visible. After selection of the start page, we should make everything visible again. I paste in the code and switch it to true. It becomes false again, loops, true, false, and so on, and when we exit the loop, screen updating will be false. And that's okay for all of this. Switch back, do the SEAC, that's okay, we don't need to see that. In the end, let's just make it true again. And let's add two small things. We go to Sheet's start page, select. We see here that we otherwise would be on Sheet simulation, and actually this code should be before we update the screen. So when it starts to update again, we are already on Sheet start page. On this sheet, choose cell A1, range A1, select. So it will be in the upper left corner when we're done. And in the very end of the macro, make a message box appear saying simulation complete. Simulation complete. Hiding sheet simulation is easy. It's just to right click on the name here and choose hide. But the thing is, if we now run the macro for the Monte Carlo simulation, it won't find sheet simulation and it won't work. So we need to enter code to the macro for the Monte Carlo simulation to unhide sheet simulation, run the macro, and then hide again when the macro is done. And we will get the code for that by a simple test macro. I unhide sheet simulation again. I go to developer and I record a macro. I call it test. It complains now because I already have a macro called that, but never mind. I hide the sheet simulation and I unhide it. Stop recording. Let's see the code for that. Here we have it. We can see it in two ways. Sheet simulation select, active window, select sheets, visible, false. That was to hide the sheet. And this was to make it visible again. Sheet simulation visible true. I will use this code for both unhiding and hiding. I copy this code, Ctrl+C, and go to macro simulation, and very early here, right after we have made the screen update into false, we will make the sheet visible. And then in the very end, maybe here, we will make it disappear again. I delete model 2 because we don't need that anymore. Remove. Do you want to export? No. And I will make some rows a bit tighter here to make it easier to see what's going on. This one I'll make a bit tighter. This one as well. And we don't need this space up here, so I do this tighter. It's very important now when we have macros working in the sheet that we don't delete any rows or columns, because that's not updated automatically in the macro, and it will all be wrong if we delete rows or columns. I move this one up a bit here. Now let's try to run a Monte Carlo simulation. I press the button simulation here, and let's see what happens. We see that sheet simulation is visible. It's not jumping back and forth. We have everything happening here on sheet start page. It's going really slow now because I am recording my screen, but I will pause the recording and go to the end of the simulation. Now we're approaching the end of the simulation, and here we're done. So we notice that the counter was deleted, cell A1 selected, and we get this message box, simulation complete. I press OK. Everything seemed to work fine, but what we didn't check was if the results were deleted in the beginning, because we had no results when we started. So I will just start one more simulation to see that the results were actually deleted. I press this button again. Yeah. The results are deleted and a new simulation is started. Now our simulation model for a health economic evaluation in Excel is done. This is a very simple model, but the principles are the same as for a more complex model. When we open the model, we only have these sheets visible: the start page, the sheet variables with the input data, the calculations for the old drug, and the calculations for the new drug. On the sheet start page, we can choose start age of our population. We can choose the time horizon of the analysis and also the study perspective. We see the results down here: costs and qualities for the two treatments, new drug and old drug, incremental cost and qualities, and the ICER. And we can also run a Monte Carlo simulation to get an ICER scatter plot and a cost effectiveness acceptability curve. We do that by pressing this button here. I hope this course has been helpful and that you have enjoyed it, and I wish you good luck in your future projects in building simulation models.